hope to see you there. But anyway, so why we're here today is that our department has been generously funded to sponsor a lecture series, and this is what we call the Zube lecture series, and it's named after Irv and Margaret Zube. Irv Zube was the head of our department, the Department of Landscape Architecture and Regional Planning, from 1974 to 1980. Right? And so Professor Zube is internationally known for his leadership in developing a culture of academic research in the profession of landscape architecture. His research made numerous seminal contributions to landscape planning theory and practice. Irv, as he's known, left UMass and went to the University of Arizona, where he continued his renowned research and teaching until he passed away in 2001. Irv and his wife, Margaret, endowed the lecture series that enables us to bring in these wonderful speakers and to have this class with you all today, right? And they established this endowment in 2004 with the purpose of bringing scholars to the department to stimulate and enrich our academic community in landscape architecture and planning. The Zube Endowment has been supported over the years and added to generously by our alumni, students, and our faculty. So we're still very thankful for Irv and Margaret Zube for setting all this up. And we honor their tradition and their contribution to the department. And with that, I'm going to turn it over to my wonderful, esteemed, and kind of newly back, sort of, in the States.
Yes.
After missing her very much over the last year, Carrie Klaus.
Thank you. Hi, my name is Carrie Klaus. I teach here in landscape architecture and also in architecture. And it is my pleasure to introduce Dr. Gabi Mocatta today. So Gabi is a climate social scientist whose research focuses on communicating climate science and climate-driven hazards, as well as building climate literacy. Dr. Mocatta is a senior research fellow in climate science communication with the Climate Futures Research Group at the School of Geography, Planning, and Spatial Sciences at the University of Tasmania in Australia. I came to know her because she's working as an editor of a DeGrooter Handbook of Community Responses to Climate Change book, which is forthcoming. I'm really excited to see the shape that takes. And also, Dr. Mocatta is currently a Fulbright Fellow. The mission of the Fulbright program in the United States is to foster global peace and understanding, which I think we need more than ever at this moment in time. And it's pretty incredible to have someone here who's on Fulbright already in the United States to share their work with us. And we're going to get a window into what is happening in Australia and the work that you're doing there. Currently, Dr. Mocatta is working with the Department of Environmental Studies at the University of Colorado at Boulder, I think for another week or a few days, and is about to sort of leave the United States and head back to Tasmania. So with that, please come on up. Thank
you. Thank you for those lovely introductions. Really appreciate it. And thank you for having me here. It's really fantastic to come and meet you all and to see what all the great things that go on campus here at UMass. So as Kerry said, I'm a climate social scientist and I focus on climate communication, climate literacy, and the knowledge that's needed for climate adaptation. So that's to introduce what it is that I'm going to be talking about today, which is really deeply embedded in those spheres. So I'm going to be discussing with you something that we've called a natural hazards atlas, which is a project that we currently have underway in my research group, Climate Futures, which is at the University of Tasmania. And I'll be describing what this project is, what it does, why we need it, and hopefully I'll be able to convince you that this project, although it's taking place in somewhere very distant from here, is part of the kind of work that we really all need to be doing in all parts of the world currently. I'd go so far as to argue that this kind of work is really needed to help communities understand the futures they face under climate change, almost everywhere. So I'm going to be talking about what we're doing, the capability that's needed, and how this work might be translated elsewhere. Before I start, just to say that this Natural Hazards Atlas for Tasmania work is funded by the Australian Federal Government's Disaster Ready Fund. So it's a $2 billion fund that the Australian Government has put towards helping communities be ready for the kinds of disasters that we're seeing and we'll see more of. So, you're probably wondering, where is Tasmania? What is that place? So it's Australia's smallest state, right down there to the south-east corner of Australia. We're quite a small state, only just over 500,000 people. For those that understand kilometres, 68,000 or so square kilometres, I put that figure in miles as well, which is the same as West Virginia, I believe, and Ireland. So quite a small place. And we're at 42 degrees south, we're surrounded by the Southern Ocean. We receive all our weather, I was telling Kerry earlier, all our weather from the west, from Antarctica. So we have these fronts coming over that drop lots of rain on the west side and leave the east side in a bit of a rain shadow. We're home to the University of Tasmania, so that's where I work. There's just one university in the state. And UTAS's work, as we call ourselves UTAS, our work in the sphere of climate change is really big. We do a lot of work in Antarctic science and atmospheric research. We do climate modelling, which my group, Climate Futures, is known for. And we do a lot of climate education, climate literacy building, so building communities' understanding of the issues we face with climate change and what to do about it. And so mitigation and adaptation work as well. Helping communities understand the changes that we need to cope with climate change. So we actually have a really huge climate research community. The Times Higher Education Ranking, which is a global ranking of higher education institutions on various parameters, has named UTAS #1 for climate action, for our research, for our education, for our outreach, and also for organisational sustainability. And that's been for the past 4 years, since 2021. So this little place in the middle of nowhere, at the end of the earth, we're actually, I think, punching above our weight when it comes to climate change work, which is a great thing to be part of. It's a deep part of our organisational identity and our commitment and our strategic direction as an organisation. And actually, Climate Futures is kind of leading this push in a lot of ways, as Kerry said, in the School of Geography, Planning and Spatial Sciences at the university. And as it says there, we actually have the highest number of IPCC, so that's the Intergovernmental Panel on Climate Change authors of any institution in the Southern Hemisphere. And I couldn't resist this. Yes, we do have Tasmanian devils, because that's what you're always asked about when you come from Tasmania. Do they exist? They look like that. You see them occasionally. I saw one crossing the road, driving home from work about a year ago, which is an unusual thing to see, but they are around. If you die in the Tasmanian wilderness, nothing will be left of you, because they are carrion eaters and they eat bones, and they eat everything. So they're kind of the trash cleaners of the Tasmanian bush, the Sarcophilus harrisi. It's the largest living marsupial carnivore, and as I said, it has bone-crushing teeth. And it actually does sound like that. I couldn't resist it. So thank you for listening. That was a Tasmanian devil in full glory. So I'm not here to talk about Tasmanian devils or Tasmania specifically. As I said, I'm really interested in imparting to you some of the work that we do and how it might be translated elsewhere. So I'm going to now start talking about climate-driven hazards and explain this project, how it is working with such hazards and how it seeks to educate people and give them the information that they need about those hazards for better planning and adaptation. So climate-driven hazards could be called, climate change here and now. They're the impacts that we're currently seeing. We know that climate change drives more frequent and intense extreme weather events, and it does so by fundamentally altering Earth's energy and water cycles. A warmer atmosphere holds more moisture and more energy, and it acts, and all of these two things act as a fuel for more powerful storms, more extreme heat waves, and also more droughts. So climate change has led to an intensified water cycle. You might know that for every 1 degree rise in temperature, the atmosphere can hold 7% more water vapour, more moisture. And this increased moisture leads to more intense precipitation events, and that of course increases the risk of severe flooding. And so while some areas receive heavy rain, rising temperatures also increase evaporation from land and from water bodies, drying out soil, therefore intensifying droughts and leading to longer lasting dry spells in some regions while flooding is occurring in others. Climate change is also leading to more intense storms and hurricanes, as you experience here in the US. So tropical storms draw energy from warm ocean water, and as oceans warm, they provide more fuel for these kinds of storms, particularly near coastlines. That also, the energy in the system and the rising sea level also can lead to higher storm surges. So that's a risk of coastal flooding for people that live by the coast, and as we are an island, we have many coastal communities, so that's a concern in where I come from. And then heat waves also are being exacerbated under climate change. So we're seeing hotter and more frequent heat waves. The overall increase in the planet's average temperature means that naturally occurring heat waves are now starting from a higher threshold or baseline, and this makes extreme heat events hotter and longer and more likely to break temperature records. The US here, of course, is well versed in extreme climate-driven extreme events. For example, attribution science shows us that the January 2025 California fires, particularly around Los Angeles, were made about 35% actually more likely due to increased temperatures and reduced rainfall as a result of climate change. So these are climate impacts here and now that we're experiencing that we need to confront, deal with, adapt to, and ideally also mitigate as well, so that we don't keep experiencing more extreme events. And some researchers have said that calling these things natural hazards is no longer accurate. There's some researchers who take the position that now we should call these unnatural hazards because they're being driven by unnatural causes. And so our Natural Hazards Atlas has incorporated, and I'll be stepping through how this works, but incorporated these particular hazards that you see on the screen. You might ask, why not drought? Drought has a kind of separate research program and funding program in Australia. So we're not modelling for drought or building drought resilience through this work. But normally drought would be one of the hazards that would be kind of mapped and modelled in this way. So climate-driven hazards cost a lot of money. They cost real dollars. This is a graph depicting the $26 billion extreme events that the US experienced in 2024 across the country. And we know that everywhere the cost of climate-driven hazards is increasing. And it's projected that by 2050, globally, annual losses for climate-driven hazards could be in the region of $460 billion to $500 billion. So there's a lot of money in real terms being lost to climate-driven hazards. Sadly, this kind of information is actually being currently impacted by the current US administration. NOAA says that its National Centres for Environmental Information would no longer update this kind of information, this database of climate-driven disasters, and that this is going to be archived, and it's just the latest example of changes to the agency that the Trump administration is undertaking and limiting government resources to deal with climate change. So not only do climate-driven hazards cost dollars, but they also cost lives. So these are just a few figures. Between 2000 and 2019, it's estimated that 489,000 people died annually globally from heat-related causes. And then pollution from landscape fires, so that's not including from fossil fuel burning, but just from wildfires, causes, it was shown in a article published in The Lancet, some 1.5 million deaths annually globally. And air quality induced deaths are actually sort of very unfairly distributed because 90% of these deaths occur in lower and middle income countries and communities. And it turns out that also flood is a highly life-threatening result of climate change. Flood events pose acute risk of climate-induced mortality. It's projected that 8.5 million deaths globally could occur from flooding by 2050. So these are real consequences in dollars, in terms of lives, in terms of altering our environments. And Australia has long seen itself as a country of extremes. In fact, we have this really famous poem by this poet, Dorothea McKellar, and one of the famous lines from that poem is Australia being a land of droughts and flooding rain. And we have always been a land of droughts and flooding rain, a land of extremes, but those extremes are becoming more extreme with climate change. And climate-driven hazards have already come at a great cost to Australia. The hazards and extreme events that we've experienced per year up to the year 2000 have cost on average $38 billion a year. And by 2060, that's under a high emissions, so greenhouse gas emissions scenario, could climb to as high as $94 billion. So, it makes sense for Australia particularly, and many other locations, including the US too, to understand the hazards that we're subject to and what can be done about them. So what can be done? Well, reducing greenhouse gas emissions will reduce future losses from natural hazards. But there's already a certain degree of global warming locked into our climate system. And so even if we were able to reduce greenhouse gas emissions dramatically now, even in line with the Paris Agreement, which already looks like it's out of reach, we would still have to prepare for and adapt to climate-driven extreme events because of the extra energy that's in the climate system that will continue to deliver extreme events for some time to come, even within a mitigation scenario. So if we're wondering about scenarios, let's talk about these then. So we're projected to experience about 2.7 degrees centigrade. I'm sorry if that's hard for Fahrenheit thinkers to work through, but it's generally not translated in the climate community because it's kind of used globally. So 2.7 degrees heating above pre-industrial average global surface temperatures by 2100 under the Intergovernmental Panel on Climate Change's SSP2 scenario. SSP, I don't know if you've come across these scenarios. What they stand for is Shared Socioeconomic Pathway. And they are climate change scenarios that project socioeconomic and global changes and emissions, levels of emissions up to 2100. And they were created for the IPCC's 6th Assessment Report on Climate Change in 2021. And they're a way to try to understand how much greenhouse gas we might emit and how we might curb that or not, depending on what our politics and our decision making is. So 4.5, that SSP to 4.5, the 4.5 is a measure of energy, and that means, not to get too technical here, but it means 4.5 watts per metre squared of radiative forcing. Radiative forcing is the extra energy in the climate system. So the extra potential for the heating that is causing potential for these climate extreme events. So 2.7 degrees of heating is what we're currently the scenario that we're currently tracking by 2100. So yes, we need to mitigate, but mitigation efforts have to be paired with adaptation and resilience strategies to manage the great risks that we face, even if we manage to mitigate really well, because of the warming that's already locked into the system. And the thing is, it's really good for us to be prepared for climate-driven extreme events because research shows, and this is from the US Chamber of Commerce last year, that for every $13, a return of $13 on every dollar invested in disaster preparedness and resilience. So it makes good economic sense to do the kind of work that I'm talking about today, because it saves us as nations money in the long run. It makes good sense. So I'm trying to build up the argument here for doing the work that we're doing. Why else should we model and map natural hazards in the way that I'm going to discuss? Well, I do work that's quite different from many of you, but I think there's one sense that we can agree, and that is it's very complicated to plan for futures and to do strategic planning, to do regional planning if you don't have this information. So we really need to understand what future climate, what future extreme hazard event circumstances might look like in order to plan for a good future across a range of sectors, and I'll be talking about sectors in a moment. So to do this at a fundamental level, we need people to understand climate risk, and we need to know what's needed across various sectors and communities included for resilience building. How do we make ourselves better able to face the future that we know is coming and that in some cases is already here? So this is where we put in this idea for a natural hazards atlas. Like I said, this is funded by the Australian government under their Disaster Ready Fund. It's really competitive. We were very lucky to get this project. It's worth, I can briefly say 3.2 million, the wrong way around, 2.3 million Australian dollars, which is only $1.5 million US dollars. But it needs a big team, it needs a lot of different types of expertise, and it needs several years. So we started this project in 2024 and we won't be finished till 27. So the Natural Hazards Atlas is a project in climate modelling and climate-driven hazards modelling that is accompanied with educational materials, translation and communication efforts and outreach, and efforts to build awareness and understanding of the level of risk that communities and a wide variety of sectors face through climate change, and to build people's capabilities and to strengthen decision making and to support adaptation across our state of Tasmania. But this, as I say, this work could be done anywhere with the right people in the room, the right tools, the right amount of money and time. This is, as I said, a 3-year project, and we're almost halfway through now. So these are the various steps, starting with the stakeholder consultation and needs analysis, which I'll be talking about because that's a component of the project which is now comprehensively done and well analysed. But I'll just briefly touch with one slide. This is usually at least a 13-week course at university, if not several courses that go more deeply into climate modelling. But I'll just touch very briefly with one slide on what climate models are and how they work. So climate models, which is at the heart of what we do at Climate Futures, they're a really important way for scientists to understand how Earth's climate functions and how it's changed in the past and how it will change into the future. So this is really what underpins the Natural Hazards Atlas. And the models are used to simulate the physics and the chemistry and the biology of the atmosphere, land and oceans. So you have these grid squares and you can add or take away any components of the climate system. And that includes human influence on the climate through burning fossil fuels. So when I talked earlier about the different scenarios, you can up the greenhouse gas emissions in a scenario to increase the radiative forcing and therefore change the parameters within a particular grid square when you're doing different models. So climate models use large supercomputing power to generate climate projections. They can take weeks or months to run models. So that's one of the key components. That's the component we're actually working on now for the Natural Hazards Atlas. So it's huge amounts of computing power to be able to create the projections. So climate models are progressively updated, they get better over time, we've learned more about the climate system, and what drives it over the last 30 years. And so they're updated, and there's different modelling groups around the world incorporate progress. They then come with the models come with higher spatial resolution, and they better understand physical processes and biogeochemical cycles. So the most updated models and the ones that we're using for the Natural Hazards Atlas are the coupled model inter-comparison project models. They use 100 different climate models from 49 modelling groups around the world. So they're kind of the gold standard that we have at the moment for creating climate models. So as well as that climate modelling capability and social science capability, which I will talk more about in a moment, we really need to drive climate-driven hazard understanding and resilience. We need accessible information. We need that information to be from short to long term, so from like the next 10 years out to the end of the century, and we need various types of data and drill downable data and information that can be accessible to all. And by accessible, I mean not just that you can get it, but you can understand it as well, because it can be complex. And you also need partnership and collaboration with the sectors that need this kind of information. And finally, once you've done this work, you need a great deal of translation and capability building. So these are kind of the steps that we see as needed in order to do something like to build something like a Natural Hazards Atlas. Okay, so who needs this information? This isn't just a thought bubble. We've done quite a lot of work to try to establish who might be part of this project with us. So we did quite a detailed sectoral analysis to understand who might need the kind of information that we could come up with through this Natural Hazards Atlas project, and we invited them to be part of the project. And these are in no particular order, but you'll notice I put planning, architecture, and built environment first, given the company we're keeping, or the audience, and obviously crucial if you're working in that sphere. But also those working in agriculture and forestry and aquaculture, which is a big industry in Tasmania, natural resource and environmental management, and then the whole spectrum of keeping ourselves living in a civilised way, so energy, water, hydroelectricity, we run mainly on hydroelectricity currently in Tasmania, and transport, and then of course health, police, emergency services, all of those things that also help to organise our lives. We've understood that local government is very interested in this information, as are councils. I don't know if you use that term here in the US, but it means like city government. So small scale, the most local sphere of government, state government and local government, and then education and research, but then also, really importantly, insurance companies are very interested in this information for the work that they do. Tourism, we're a big tourist attractor with our incredible natural environments down in Tasmania, and we have experienced natural hazard events where tourists have not been communicated to around what was going on and have been put in danger as a result of that. So tourism is a key sector here as well. And of course, last but definitely not least, communities, people, everyone needs to understand. So, this kind of information. Just to give you a quick stat, in Tasmania, 95% of the population is at medium, high, or extreme risk of bushfire. That's wildfires in our language. And this includes health risk from bushfire smoke, because we're a very forested landmass. And 70% of people are at risk of floods. So lots of implications for these kinds of risks. So NHAT is our abbreviation for this project, Natural Hazards Atlas for Tasmania. We started with this multi-sectoral stakeholder consultation. So we did a big survey, we did a bunch of interviews, and we did several workshops at the end of last year and early this year, which was fun and informative and helped us to really understand the community that is going to need this kind of information. A couple of snapshots from some of the workshops that we ran. We consulted with overall 200 stakeholders in our state, and we've done a really detailed needs analysis from the data that we collected through all of this. We did 4 workshops in different locations, one online, and like I said, a bunch of interviews, 30 plus interviews. We had climate scientists and modelers and climate social scientists in the room. And as you can see in that image, you may not be able to see, but there were our fire service engaging with others, state government and so on, and we are sort of eliciting a lot of information from them. We made them work really hard. So what do we do? How do we work with the stakeholders? And I guess I'm explaining all of this because I'm looking to show you how this could be replicated. Like what did we actually do? What were the steps and how could you do this elsewhere? So we started with a climate and weather 101, like what's the difference between climate and weather? Very briefly, and then we got more sophisticated from there. We talked about climate modelling, and then we took them very quickly into a climate risk assessment. And so we went through, we said, for example, if you were, this was an example we gave them, we asked them to do it for their own organisation. So if you were an electricity network operator, what is your organisational objective? And then what are your operational systems or processes? What do you do day to day? And then the kinds of natural hazards that could impact on those processes. And if you wanted to plan for those processes, what kind of climate and weather parameters would you need to know? So if you were that electricity network operator, you might need to know about lightning and daily maximum wind gust speed and air temperature, and so on. So what were the indices that are pertinent to the operational goals of your industry? And then how would you like to access that information? So drilling down all the time, what kind of format, how would you like that to be presented? How could you best understand it? And how would your organisation best make use of that kind of work? So that was a very brief introduction to a climate risk assessment. Then we wanted to know which hazards were of most importance to the sector, to each different sector. We wanted to understand their timescales for planning. So are they planning 10 years out or 50 or 25 years out? I'll tell you about that in a moment. We wanted to know what kind of resolution they needed for the modelling that we would then produce information from, and like I said, how might they want to access this information? Like, would they want it delivered to them in a seminar, or access it online, or do they want to download graphs, or do they want to see? I'll show you some more examples in a moment. Or do they want online training, or do they want us to visit them in their offices and explain what we produce and how they can use it? So a lot of that. I'll just skip you quickly through a few slides of what we found for people, and then we'll talk a bit more about next steps. So we understood that bushfire and flood, of course, understandably, were of broadest concern to the most sectors, but people were also really worried about sea level rise, and that was particularly of high priority to insurance, given that we are quite largely a coastal community, and there's a lot of coastal infrastructure that's subject to sea level rise and storm surge threats. And storms and heat waves were also a significant concern. We went through all these, probably quite complex, and I won't detail them now, but all these complex quantitative parameters, and we were able to distinguish which parameters we need to kind of produce a model for out to 2100 for the different sectors. So we know which sector needs what now, which is fantastic. We also talked about spatial scale with the stakeholders that we engaged with. And it turns out that everyone wants the finest possible spatial scale of less than 1 kilometre. So that takes, of course, more computing power and a lot more time, but it is what's going to be most meaningful for people's planning. And we asked them how far ahead they were planning, and you can see the different sectors obviously had slightly different planning horizons, if you like. But overall, most planning is short term. So quite surprisingly, only 10 to 15 years into the future. and there are very few planners across all these different industries and sectors that are planning for climate impacts and resilience building right out to the end of the century, 2100, which I don't know if you find that surprising or not, but that short-term timeframe I think we found quite surprising. So you can tell me if you think things are different in this country, but it looks like short-term planning was prevalent there. And then we also asked people what they understood about future emissions scenarios and which ones they currently were using in their planning, if any. And I think there were many respondents that said they weren't using any, but those that were actually planning for a higher emissions scenario, so with more heating than the one that we're currently tracking, interestingly. So they were using SSP, the Shared Socioeconomic Pathway 3, the IPCC's SSP 3, which is it's a climate change scenario resulting in high greenhouse gas emissions and potentially significant temperature increases up to possibly 3.6 degrees of global temperature rise by 2100. So quite a bit more than we think that we're facing by 2100 on the SSP2 scenario, which is 2.7 degrees. So they're actually planning for a worse case scenario than we think we probably will be facing. But there's also quite a lot of planning occurring that's underestimating the risk and the heating. So there was quite a lot of planning occurring still with in line with the Paris Agreement goals of 1.5 and even 2 degrees. So these are really interesting things for us to know. And so the modelling will be done across a range of scenarios so that we can, we don't know how emissions will be reduced or not be reduced, and so we need to monitor a range of scenarios. Okay, so now to representing the hazards data. And I think that little sentence at the bottom says it all, that having this information should be helpful. It shouldn't hinder us. It shouldn't make the work of planning and resilience building more difficult. So an endless and bewildering spreadsheet, like the one you see on the left, is really of little use when you're dealing with an incident like you see on the right of the screen. So the thing is, we want to tailor information that can be, we want to produce information that can be tailored to meet the needs of those using it, to allow for faster and more accurate decision making. Now, we don't know exactly yet what the outputs will look like for the Natural Hazards Atlas because we're currently building it. I can, however, share some examples from 2 previous projects which we presented to many of our stakeholders, and they said, yes, we want that, and no, we don't want that, and yes, we want that. So we're able to understand what's most meaningful to people in terms of providing them with hazard information. So this is just a real quick one. Of course, people want infographics, pictorially presented information. You might think this is simple, but actually huge amounts of data underlie this infographic, and a huge amount of modelling has gone into just producing the simple figures that you see on this screen. So this is an example from a previous project we undertook. It was called Australia's Wine Future, a Climate Atlas, and it was an extensive publication that we undertook, a big project over 3 years with the wine industry right across Australia, for them to try to understand future climate and to plan for it, because wine is a long-term planning effort. You can be planting your vines now for 20 years down the line. So this is something that was like a predecessor to the Natural Hazards Atlas, particularly for the wine industry, and helped us to understand that each sector needs very specific information for its planning. So our stakeholders for the Natural Hazards Atlas said, yes, they want this kind of thing. So they want kind of quite simple infographics for data. But then other sectors want this kind of thing, so much more complex, drill downable. This is reproduced from the publication of the Australia's Wine Future Climate Atlas, but we plan for the Natural Hazards Atlas to be an online portal. So if there's this information, it might be like several layers down, and you can then drill down into it and produce the information with the parameters that you want for your sector. So we can go from simple looking infographics to something much more complex, and lots of things in between as well. But what we won't be doing, I think, is probably like the image on the left-hand side of the screen there, that was universally rejected by our stakeholders. So where are we currently at with all of this? So our stakeholder engagement and needs analysis is completed. We are now in the I said we because I've been here in the US for the last several months, but my colleagues are currently working on the technical phase of the climate modelling and deriving the quantitative hazards parameters. So doing the work that's all in the background of this beautiful portal that they're going to build online. And doing the climate projections work using, as I said, the CMIP 6 project. And this will be downscaled, I won't go into that, but global models usually have very large grid squares that can be up to 100 kilometres. Tasmania is only 400 kilometres across, so we need a much finer scale kind of model, so that's going to be downscaled for higher resolution in Tasmania, in some places up to the requested 1 kilometre grid square. So we plan by 27 to deliver a user-friendly web platform, which I said, I don't know if this is a word, but I'll use it anyway, I think you know what I mean, very drill downable, so there'll be multiple layers into which you can dive, and sector-specific information, so you'll be able to put in your sector, your needs, the kind of information that you need to derive from the platform, and then the way that you want to interact with that data, and you'll be able to download that information that helps you to undertake planning and resilience building. We also, if there are any budding PhD students here, we actually have a PhD project for a mobile phone app, which we think is not just going to be a phone version of the website, but something slightly different. We've been advertising that project, but we've not so far been able to get the ideal candidates. So if you know anyone who has, I'm just working for this now, who has expertise in app building and stakeholder consultation, and not necessarily climate science at all, but maybe communication outputs around this, we'd be really interested to know. We have a PhD project and we want a student in that project. So, and that has like a consultation process of its own, so there'd be a lot of trying to understand what people need in a mobile app. And then a lot of co-design and targeted data and communication materials to help people make their way through all of this. A couple of quick examples. This is something that has been undertaken by the state of Queensland, which is in the northeast of Australia. They produce particularly climate risk information for rural parts of that state. So this is we'll be better at this, we'll provide more, but this is particularly for the rural sector. And so it's a state government effort to provide the kinds of climate risk information that we're doing across a whole bunch of different sectors for the rural and farming sector in Queensland. Canada also has an amazing portal with climate risk information, but not with the number of different types of hazards that we're looking at. So we think that the portal might be something like this, where you can set your variables and your time period and the types of hazards that you are interested in, and perhaps in your sector on the side of the screen, and put that all in, and then what pops up is a multi-layered piece of information that's relevant to you. And we also think there's going to be a bunch of these kinds of things, info sheets, downloadables, regional climate information. So we are a small island, but we still have very distinct regions because of our geography, basically our climate. We have microclimates, so it's quite different in different parts of the state. So there'll be regional climate information for cities, and also probably printouts or printoutable sector-specific climate. And I mentioned that app. I've probably already spoken to this. It is going to be designed in a separate co-design process. We think so this is not to be misunderstood as a an emergency app. You couldn't look at it and go, oh, there's a landslide near me. Well, landslide isn't one of the hazards, but there's a heat wave near me right now, or there's a bushfire. It would be more an informational app rather than real time. So it's not an emergency app, but it's something that we are yet to build, and that should start this coming year. And then finally, there's the task of bringing back all the stakeholders and saying, this is what we've done, let us show you how you could use it, and make it meaningful for them. So we are planning training in person and online. We're planning workshops and webinars to help people get the most out of their MHAT, and we may even, given that we're university lecturers, and this is what we do, we like to teach. We teach climate change in all sorts of ways. We might try to put together an open online hazards information course, which would be relevant to our state, but other places as well. And so by 2027, we'll be in full capability building mode, kind of showing and telling what it is we produce and how it can be useful to the different sectors that we've been working with and the community more broadly. So I'm nearly done, but I just wanted to end with a kind of wrap up of what might be needed if this were to be done elsewhere. We know that this kind of work is happening in different places, but we think that our project is unique in the way that it speaks to multiple sectors and seeks to deliver sector-specific information and focusing very much on the communication outputs and the capability building. So what's needed to do this? You need, of course, the climate modelling expertise, you need local hazards knowledge and expertise, and you definitely need the climate social science stakeholder engagement kind of expertise as well, which I'm sure you have. You just need to bring the right people into conversation. You need that really close engagement with your stakeholders and understanding of their needs. And I'll distinguish, as a communication scholar, I guess, distinguish those stakeholders from your audience for communication. Who is it you're speaking to? What do they value? That's really important as well. You need to understand a little bit about climate literacy building, what people know, what they care about, what they want, and how they want to access that information. And then you need money, so you need some good funding. We are lucky to have this funded by the federal government, but you also need expensive and hard to access computational capability, and as I mentioned earlier, for the modelling work. And you ideally need a really large team and a diverse one in terms of skills, and that's what we are. You need the capacity, the money, the time to do a major website build, and then you need that capacity also to outreach and translate and sit with those that you've done this work for and say and work with them to help them understand how it benefits them. And I guess you need a lot of time. This is a 3-year project. We're already feeling the clock's ticking pretty fast, but we are getting there, I think. So that's all from me. I hope it was of interest. I'm not leading this team, but I'm part of it. And thanks also to our funders. If you'd like to be in touch, we do have a Natural Hazards Atlas email, or you could email me. So I'll put that up there. So thanks so much, and very happy to take any questions.
Hi, I'm just curious. So I understand this is for Tasmania itself. Would you expand this to Australia?
It's a really good question. We want to do that, of course. We want to conquer the world. We would like to do that, and we have been in conversation with other modelling groups because we're not the only one that does this kind of work in Australia. So ideally, yes, but we're a small state, the size of what did we say, West Virginia, and it's taking 3 years and $1.5 billion US, and a bunch of people. So to do this work for the whole continent of Australia would take a lot more capacity, but it'd be great to do. Yeah. Thanks for the question.
This may be an unfair question, so I'll apologize up front, but In the stakeholder analysis part, the example you gave was utilities, but electric utilities out there. But I didn't see on there the risk of fires from power lines failing and therefore the risk of utilities turning off their lines. Did that show up in your stakeholder?
Definitely, and as I'm not, I know we have someone in the room who is an expert in this area, but I'm not an expert in this area, but I understand that heat is a risk. So the hotter it gets, the more risky it is that you would have power line fires as well. So definitely, no, that did, heat waves and wind events and storm events that can jeopardise power lines in that way are all factored in. And that's why we had, I don't know if that's why we chose that example, but that's definitely why we had the power utilities in the room, because they're worried about this kind of thing. Yeah. Does that answer your question?
Yes.
Questions? You can ask me about Tasmania if you want. You don't have to ask me about the project. Sure.
I don't have this framed up quite right, but I'm curious about, does Australia already have like a national climate assessment? And like what was I'm trying to understand the need to do the intense modeling you're doing. Like I always wonder how much modeling we already have versus what we need. Like if you could just talk about that a little bit, that'd be great.
Yeah, we do have a national climate assessment and we are currently seeking to update assessments with the latest, the CMIP 6 modelling, because that modelling hasn't been done and hasn't been done in a regionally downscaled way across all of Australia. So the need for Tasmania is, I mentioned earlier, because we're quite a small island and very geographically varied, and with the kind of global climate model grid squares sometimes being like 100 kilometre grid squares, we're only 400 kilometres at our widest part. And so you could have, within that grid square, you could have an alpine environment and a coastal plain. They have very different climates, but they fall within that grid square. So you need to do much more fine scale modelling. So that's why the intensity, the small scale of the modelling and the hazards information needed for our state in particular. But that is probably not the case across Central Australia, for example, where, it's quite uniform for very huge distances. But I think in general that the effort is always to update as we get better at climate modelling and more groups are contributing towards the global climate modelling effort. We can't sort of stay static. We have to keep moving, doing better. And in fact, the latest generation of climate models is showing we maybe have underestimated the degree of heating. So it's definitely really important. It's informing us. The better we get at modelling and the more we do it, the more we can understand about current conditions and future climate, if that makes sense. Thank you.
Hi, you've mentioned earlier that you encountered some unexpected feedback from your stakeholders. What is the unexpected setback that you've encountered in your research so far, and how have you overcome that?
You mean in this project specifically?
Project.
Did I say that? I can't remember.
You said something about how the stakeholders, some of the responses were unexpected, and I was just wondering what are some unexpected setbacks?
Oh, okay. I think I did. What I did say actually was that we didn't realise that stakeholders would be wanting such fine-scale climate modelling, so that's not a setback. I guess that's a challenge. But this whole project is designed to be really responsive to what the sectors that need this information want. There's no point doing it if we aren't giving them exactly what they want and need. So I don't think we see that as a setback. I think we see that just as a guide to how to run the project better. Does that make sense? Yeah. Sure, yes.
Sorry. Have any sectors reached out to you while you've been doing this to ask, any maybe private companies or any have asked to be included in on the surveys while you were doing them?
Yes, they have. definitely. And more than that, actually, we've been, so one of the entities that's reached out to us is a project that delivers like local information on just, I think just bushfire, and I think maybe it's just bushfire information, and they want our data to feed into their website. So we are doing that kind of work where we're going, well, we're not just producing this for those that have stated an interest, we're producing this for everyone. And if we can feed our data into your website and more people can access it, so much the better. So definitely anyone puts up their hand and says, we want to be part of this, we want to include them. Yeah.
Dr. Mocatta, I was wondering if you could talk a little bit more about the app that needs to be developed by some lucky PhD student. Because we've been trained over the last couple of decades to respond to social media and be involved and always carry our devices. So it's a very useful tool. We may as well gather information. And so I'm wondering what your conversations have been about how interactive this app has to be, and if there's any more, if you can fill us in on how you want that to be shaped.
Yeah, it's a really good question. Well, we're hoping the PhD student is going to define all of that in consultation with stakeholders, but it would be wonderful to have an app that's both informational, like educational, but also can collect data. Because we know that the gold standard of science communication, which is kind of what underpins all of this, is participatory science communication and citizen science, where people can be involved in collecting data. And certainly an app is very capable of doing that kind of thing. So I would love to see an app that not only informs but also collects data in an ethical way, in order to better inform the effort to be resilient in the face of climate-driven hazards. So yeah, that's a really good point. This is, after all, science communication, and we know that the age of just giving people information and saying, now you understand, or you should understand because I've given you that information, that's over. It's all about interacting, including people, co-creating, as we've done with this project, and then going back to them and saying, so what now? What do you think? How could we make this better for you? And an app could do that too. So yeah, good question.
I'm curious, when you said, just go off that question I was just asked, you mentioned how the communities could collect data. How would that be, like how would that happen, or how would that work?
Well, that's going to be our PhD project perhaps, but I mean, so I know that there's a bushfire app right now that prompts you at particular times of year to clear your excess vegetation on your property and to speak to your neighbours about it. And I think it has like a response thing where you go, I have cleared my property. And there's even conversation about, and I don't know the ethics or the privacy of this, and that would have to be worked through, but there's conversation about sharing that kind of information with insurers, and that you can then qualify for a low insurance premium if you have done the clearing work that's needed to make your house safer in the face of bushfire. So I guess it would have to be some kind of interactive capacity in the app, not specifically that, because that's been done already, and not specifically to work for insurance, but to maybe spatially map who's using this information, what kind of information they're looking for. I don't know. We haven't crossed that bridge yet, but we're interested to think it through.
I think that would definitely attract more users to it as well, if they had to do something like not exactly like that, but something that's in that realm, like you just mentioned. So, but I think
benefit from it somehow. Yeah. So that insurance idea, that's been proposed by fire services in Australia, and it makes really good sense because we have very flammable vegetation in Australia, but if you clear sort of a area with less or no vegetation around your house, it reduces the risk hugely. So if you could get some kind of benefit from that, like reduced insurance premiums, that could be a really good incentive for people to actually get out and do it. says the person whose insurance premium just went up by $1,000 because we're in a severe bushfire risk zone from year to year, $1,000. So, yeah, anyway, it's another story.
Right, well, we're at 5 o'clock, but maybe we have time for one more question, if there's somebody that still has one. Last question? Going once. All right, so how about a final round of applause for Gabi Mocatta?